So today we're going to be doing a little bit of review, doing the last new thing there is to do. So as I have said a couple times, you are opening your packet to page 45. And there are two questions on page 45. First, you're labeling the air masses up here. That's what we did last week. And then down below, I'm asking you to draw a weather station model. Make sure you read the actual question because it does give you a question mark for the cloud cover. But it says using the information determine what the coverage would be and shade in the station model according to the cloud cover. Or according to the other data, figure out the cloud cover. So again, we're doing page 45 right now. So the first air masses stuff was on page 38, if you're confused on how we did that. And then the weather station model, those were on page 41 and 42 and 43 and 44. So with the map here, please don't just copy it from your last one. Make sure you know how to get those letters, where they come from and what they stand for. We'll start right at 8:30. A couple more minutes. Page 28 and 37. So yeah. Brennan. 28 and 37 from you. And 24 and 26. So 24, 26, 28, and 37. Do you have them done? No, they were from. Okay. You are 28 and 37. I saw 37. Okay. Oh, it was about 20 or 48 when you were out. All right, let's do that. So these guys, these were asking for the air masses. It's saying these are the source regions. That's how they describe where they were born. So the source is like where it came from. So this is saying the air masses were formed here. And then if you take a look at the arrows, that's where they're going to blow to. So we just have to label these with the correct symbol. When you ask, well, what are those correct symbols? The only choices for air masses. I would highly recommend, because it did say label the air masses. Sometimes people want to label them with the fronts, but we are talking about the air masses, so they all get the 2-letter symbol. If you don't already have this labeled, let's go through. Which one is 1? MPYM. Right, so M's are always for when they form over water. The opposite of an M is a C, like this one will get a C. Why does this one get a C? Because it formed over land. And this gets C what? CP. What are the P's for? P's tell you it's cold. The opposite of P would be a T, and that's warm. We always describe whether they're wet or dry first, and then whether they're warm or cold after. So how about number 3? MP, that one is wet and cold. How about 4? MT, wet and warm. 5, CT, and finally number 6. So that is not overly complicated. The only thing this didn't ask you to do was describe whether they would be wet and cold, wet or dry, warm or cold. So again, if it's over water, they're going to be wet. Over land, they're going to be dry. And then polar is cold. Again, you do need to know those. Then this asks you to draw the weather station model. So one of these guys, I always recommend starting with a circle. Wind from the north, wind in the northeast. Which corner is the northeast? Upper right. Wind speed 20 knots. How do I show that? 2 lines. It does not matter if they go down or up. So I just went down, but again, they could have gone up. Make sure it doesn't matter how long your lines are, as long as they're clearly about the same length at least. Because remember, a whole feather is 10, half a feather is 5. So don't make that look like they're different lengths. Hail, I have to check my notes for hail. Hail is a triangle. Where does that go? Yep, right there. Quarter mile visibility. 4. Where's the temperature go? Notice I'm not writing anything besides the number. No little degree symbol, no Fahrenheit. If you write that, then it's wrong. And then the dew point's at the bottom. Now, it did ask you, even though it gave you a question mark here, the direction said to figure it out and draw it in. How much clouds would there be on this day? How in the world did you know there'd be 100% cloudy? That's what's happening when temperature and dew point are the same, like in this one. It's precipitating, raining, snowing, sleeting, or in this case, it's hailing. So when it's raining, snowing, sleeting, hailing, what's the cloud cover? Yeah, 100%. It's cloudy if it's raining. That is a typical Regents question. It makes you test 2 parts of your knowledge. First, I do think it would have been 2 separate questions on the Regents though, for the record. The first would have been, do this. And then the second question would have been, well, what's the cloud cover going to be? So that's the stuff they love to do. They like to check that you know how to use your reference table and then check your knowledge that temperature and dew point are the same. That means it's raining, and if it's raining, you should have 100% cloud cover. All right, so on the board, I do have your homework listed. It's 46 and 47. I kind of want to get a head start on 46 before, because this is more like review of what we just did on Friday than complete and utter review. I also put up there chapter 7's test is going to be on Wednesday. Did everybody here get their quizzes back? Isabel, you missed the quiz, didn't you? Did you take the quiz? You took the quiz. Anybody else want to take the quiz? Okay. Do you want to take it now, later? When do you want to take it? Right now? Okay. If you just want to run to the library, it'll only take you a few minutes. It's just 11 questions. Starting off question, what do you actually do? It looks like you should be able to do, see if you can do questions 1 through 10 right now. It's gonna be your homework, but I kind of want to do it together right now. Yeah, I do. Not. Okay. Oh, it's gonna be easier. So again, do questions 1 through 10 right now. Check your notes. Okay. Say it again. What are the choices for air mass? You sure? Check your reference table. What's the title of that page? Is it that different? No. There you go. Warm milk. What's the symbol for warm air, warm, moist air mass? So that's the first question, and I've already heard the confusion that I thought was gonna happen. A lot of times when you hear about the warm air, you guys want to talk about the front. It's not asking about a front yet. It clearly states air mass. Again, you check your reference table for masses. These are your choices for warm, moist air. Which one of these stands for warm, moist air? MT, the M is the moist part, the warm is the tropical. So on the same note, what about cold, dry? That's continental polar, C, heat. Now they're asking, according to this map, because we are using this 3 through 12, where did the warm air mass originate? So first things first, we got to find the warm air mass here. Here is the warm air mass right here, warm, moist, MT. And they're asking, where did it originate? And hopefully you know that the word originate means where did it come from, or where was it born, or where did it begin? And we can figure that out from the reference table. Anybody have any ideas? All right, so since you don't have any ideas, can you tell from the reference, or can you tell from the map which way the air mass is going? That you should be able to tell. What about this tells us which way this air is moving? Somebody said it, the circles. These half circles, they tell you which way it's going. So remember that the circles or the triangles or whatever shape they're looking at on the front, they're always pointing to where it's going. So this air is going this way. So where did it come from? How do we figure that out if we know where it's going? Kind of read those arrows backwards. So if it's going that way, it means it came from back here somewhere. And does anybody know what this is? And if this was a Regents question, this area would have been labeled. Oh, wait, maybe it wouldn't have been. Let me check your reference table to see if they label it. Nope, they don't label it on your reference table, so it would have been labeled on the Regents. Anybody know what this place is? That's the Gulf of Mexico. Now that I explained how to figure out where the warm, moist air came from, how about you guys tell me where the cold air mass originated? Do the same thing, find the cold air, see where it's going, and then read it backwards to see where it came from. Anybody have any ideas? So again, here's the cold. No, probably not. Yeah, Canada. Here's the cold air. It's going this way. And so where did it come from? Well, somewhere back here. And yeah, that's Canada. Do you guys get to 7, 8, and 9 yet? Yeah, okay. Weather station, and I covered them up. Weather station A, weather station B, weather station C. Which one has 100% humidity? I gotta uncover mine. Give me a second. I was going to go with that because that was the one I can't see. How did we know that weather station B, there we go, has 100% humidity? There's two different ways. Temperature and dew point are the same. Guys, what's happening when temperature and dew point are the same? Precipitation. And if water's coming out of the air, the humidity has to be 100%. The Regents would have also accepted the fact that, and somebody said it over there, that it's so cloudy, odds are it has 100% humidity. Which one is going to get colder in the next couple of days? Is it going to be B? Where the heck is A? There, A, B, or C? A is going to get colder in the next couple of days. Can you explain how you knew that? The cold front is coming for it. Remember how I said the triangles point to where it's going. I kind of think of it as them pointing at that city and saying, ha, 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 A, I'm about to make you cold. So A is about to get cold. Yeah, hopefully you remember it that way, Logan. In which direction is now careful with this one, the wind blowing towards at station C. Here's station C. Which way is the wind blowing towards? So they've got the stick for this weather station. What side is the stick on? That's the northwest. According to our reference table, the wind is not the direct, it's labeled as the wind is coming from. So if the wind is coming from the northwest, which way is it going? Southeast. Basically, just again, if that's the butt of the arrow, add the head of the arrow. It's going to the southeast. And then I'm asking for 3 things that made you know that this was a low pressure system. There should be one really obvious one. The L. One would be the big L. What's some other things about low pressure that we know about? On the lines themselves, is that what you're saying?
Whatever numbers on it, lower it out. I don't know how to put that in.
Yep. These numbers are low numbers. Let me tell you again how you know if they're low. Here on, so we're on page 13 on that pressure chart that we've been looking at. This is considered about average. So around 1,013 millibars is considered around average. Anything below that is a low pressure. These numbers are all low. So they are actually, so the pressures are low numbers. And then the third one is going to be about the wind. Which way does wind blow around a low pressure? Counterclockwise. Remember, I had you remember that because the counter is low, so low is counterclockwise, while the clock is high on the wall, so high pressure go clockwise. So are the winds blowing counterclockwise around the low? There's a couple ways to look at that. Remember, I told you, you could look at just the fronts themselves. They're blowing this way and then this way. Or you could look at the weather station models. They're blowing that way. Oh, here's another one, and then that way. They are going, the fronts are going counterclockwise, but what about these weather station models? Which way are they pointing? In. Again, which way does wind blow around a low? In. So wind is blowing towards or into, towards, and counterclockwise. I might as well do the last question on this page, just have you do 47 for homework. Which cross-section below represents air masses, air movement, clouds, and precipitations occurring behind and ahead of a warm front that is seen between stations A and B? So we're still talking about this warm front, A and B. First thing I want you to notice is that A is here behind the warm front and B is ahead of the warm front. So is A warm or cold? A is warm. How do we know A is warm? You could look at the map and you can see that the temperature is warmer than B. There's another way to look at the map and see that A is warm. That's not quite going to tell us that A is warm, though. Where's the warm front? It's in front of A. The warm front's already passed over A. So we know that A is warm. B is cold. The warm front is coming for it. So the warm air is behind the front. Which way is the wind blowing? Towards A or towards B? towards B. Knowing that, can we cross off some answers? I can cross off which one? No, I can't cross out everyone. Which one can I cross off because the wind is blowing? 1 and 2. So that's because, why am I crossing off 1 and 2? There's an easier way. Which way is the wind blowing? And 1 and 2. Towards A. See how the wind is blowing towards A in 1 and 2? And how it's blowing towards B in 3 and 4. Right. I can cross off 4 because A is warm air. So that leaves 3. What else about 3 makes it correct? What's the warm? The warm air is rising. Here in 4, the cold air was sinking. So that can't be correct. All right, so your homework is 47. We do have to quickly go back to page 28 to get the very last thing that I apparently skipped over weeks and weeks ago. And this is called the Coriolis effect. Coriolis effect is kind of a neat concept. And for this explanation, I'm gonna need a globe. And I'm gonna need you to use your imagination a little bit. I am not an expert in football or hunting, but I am going to try my hardest right now to use those analogies to help you understand this concept. So let's talk about football first. Are any people up there? You're not a thrower, are you?
No,
Are you a thrower? Are you a catcher?
no.
What do you do? What else is there? That's what it's like when you have about science for you. Okay. Are you a thrower or a catcher? Okay, can one of you guys pretend to be the thrower? Yeah, that one, I did know that. All right, we got the quarterback. Throwing to, and I've watched enough football that most of the time the players are not standing still when you throw the football, right? They're moving. I'm not wrong yet? Okay, so most of the time the players are running around. How the heck does Josh Allen then get it to the place they're going to be? Where does he throw it for? And he throws it in front of him. I can now relate that to hunting for those of you who hunt, because again, are the deer typically standing still when you shoot them? Sometimes, if you're lucky, I'm guessing if you're lucky. Okay, I think I'm not an expert hunter, but most of the time the deer move. So you shoot in front of them. You guys understand Coriolis effect? Awesome. So the concept that you have to throw the ball in front of the moving player, because if you throw it to where they were when they were moving, where does the ball go in? Behind them, or not where it's supposed to. Concept is pretty similar with Coriolis effect. And now here's the imagination part. So you're Santa Claus up here at the North Pole. You've gone and done your duties on Christmas Eve and your Christmas Day. And you get home and you realize that one present has slid under the seat of the sleigh. So you don't really want to go back out, because if any of you know, after a long day of running errands with your parents, what would be the last thing you want to go do is get back in the car and go do that errand again. So Santa Claus has developed a plan for this, and he shoots a missile. Whatever. So you shoot a missile, or I guess if you want to use a less mean sounding, you send a drone from the North Pole to wherever that person who's supposed to get that present lives. So Santa Claus is up here, and the present has to be delivered to, I know, oh, there we go, right there. We're going to, no, it actually looks like your house, Logan. Okay, so there, if you notice, I got a big blob right there on the globe. That's where we're going.
Yeah.
Now, Santa Claus is up here. Recall the Earth is spinning, though. No, because he's not leaving. He is standing on his front porch. sending this missile slash drone slash present delivery system. Can he, just like the quarterback, can he throw it straight at Logan's house? Okay, that's why I don't like the idea, that's why I like the missile. The missile is shot and you cannot change its direction once it's already started, so that's why I don't like the term drone, because you're right. Okay, so again, you have to use your imagination to work with me here. Can Santa just shoot that missile straight at Logan's house to get it? No, because it's not that kind of missile. Okay, so it's a present missile, it's a good thing. So he sends that missile, and just like when you're sending the football, if he sent it straight, well, that's great if the world wasn't moving, but you guys know the world moves. So if they sent the missile straight from the North Pole down to Logan's house, they'd end up missing Logan's house, and somebody to the west of Logan would have ended up getting his new iPhone. You don't want an iPhone? Oh, you do want the iPhone, you don't want somebody to the west to be getting it. Yeah. Coriolis effect is the same idea, except for instead of footballs, bullets, or missiles, we're talking about the wind. When the wind blows from a high pressure to a low pressure, it's going to appear that it curves. Just like that football, you can't throw it straight, you gotta throw it ahead of the player. So just like that, the wind will curve due to the spinning of the earth. Again, is the wind actually curving? No, the wind is going straight, but it appears to be curving due to the rotation of the earth. I have a video that will kind of demonstrate this a little bit better than I can. So, Logan, do you mind grabbing the lights, please?
Of things, and this looks kind of complicated. I guess that might be because our universe is ultimately kind of complicated, but this is a lot simpler than that this is kind of showing way down below underneath our universe.
Yeah, I never fixed it after daylight savings time weeks and weeks ago. I have no idea. That is not what I wanted to show. Oh, okay, way to make it weird. Way to make it weird. Me, I'm struggling, that's what I'm doing. Okay, now that we're ready. All right, here we go. So, I don't know if you guys recognize what this is, because you're pretty old now, but yet, you know what it is? Okay, you guys do know it's a merry-go-round. Is there still one of these around here? Yeah. Okay, so you guys are like the last playground in the country, I think, to have one of these. Because they've been removed from every other playground because kids get hurt on them. Yeah. So you guys are the last tough kids in the country, I think, yeah? Let me guess, you got hurt on one of these, didn't you?
No, I've seen somebody get
it. What did they do?
This video.
Oh, okay.
And these people took their crotch rocket and like canned it. And guess what they were going around? That's all they went.
Yeah. So without the motorcycle, they're just as dangerous as when somebody gets them going fast.
Especially the person that's spinning you around.
Yeah. So I cannot believe, I will not tell the authorities that you guys still have this dangerous piece of equipment. I cannot believe it has not been removed. I think it's pretty cool though. I also hear you got one of those really tall slides still. Yeah, that's also been removed from every other playground in the country. So nice tough kids here at Pioneer. So somebody must have forgot that older one exists. Yeah, do not tell the mayor of Arcade or whoever it is, because that might have to get removed. Wait, we only have a few minutes. Let's talk about this. So clearly it sounds like most of you understand what this is. If you do not know what this is, it's like a merry-go-round at the fairs and stuff. Just it's on a much smaller scale, and you power it with your own muscles, and there's no seatbelt. So what we're going to be doing If you can't see, we got a couple of kids and then a ball. They're going to throw the ball across the merry-go-round. Just like the wind blowing from a high pressure to a low.
To an observer above the merry-go-round, the path of the ball appears straight, while to someone sitting on it, the ball appears to curve to the left. This exemplifies the Coriolis force, whereby, to an observer on the rotating Earth, the path of an object appears to be deflected, and this is a result of the Earth's rotation.
Get motion stick on them. Let me see if I can.
To an observer above the merry-go-round,
So they must have got it started and it's just going. So if this was not moving, which, if it was just sitting still, if the kid in yellow pushed the ball, where would it go? To the guy in the green. To the kid in the green, if it wasn't moving. So if he pushed it straight, it would go to the kid in the green. Is the kid in the green, now that it's moving, going to be able to get the ball?
No.
No. But notice that ball will still end up in this corner of our screen.
go-round,
Look, that ball is still in this. Oh, it was going the other way. Sorry. Sorry, it was spinning the other way. My mistake. It's still in this corner of the screen. So did the ball still technically go straight? Yeah, it did, but who caught it? The other kid, because the kids are moving. That's the Coriolis effect. I would like you to get this into your notes real quick.
Yeah, miss.
What? Faster? Did you just tell me to go faster? All right. Here are the notes that need to go on the top of page 48. And this is that the winds appear to bend. So the apparent bending of the winds and ocean currents due to Earth's rotation. And this is on page 28. This will be different depending on if you're in the northern or the southern hemisphere. In the northern hemisphere, all of the winds will bend to the right. In the southern hemisphere, they will all bend to the left. I remember this, and again, another cheesy, corny way, but we live in the northern hemisphere, so of course we're right. That's what I say.
Yeah.
Don't pack up quite yet. We still have 3 minutes. I would like you to open your reference table to page 14. 14. Well, the same thing would have happened, except for probably with some injuries. So grab your reference table, open them up to page 14. We have used page 14 plenty of times by now, but we did use the bottom, we haven't used the middle. So here's the wind. Flowing from high pressure to low pressure. So you'll see there must be a high pressure up at the North Pole. There must be a low pressure here at 60. High pressure at 30. How do I know there's a high pressure at 30? No, it doesn't say anywhere on there that's a. Well, one could be the clockwise. The other would be that the winds blow out of a high. Remember how I always talk about farts? Well, they're coming out of the butt of an arrow, and then they go to your nose, which is on the head of the arrow. But wait, if we look going from 30 to 0, does that look like the winds are bending to the right?
From what? Yeah.
From 30 to 0, let me put my hands here so you can see my left hand and then my right hand. Does that look like they're bending to the right? No. That looks like you're pointing to my left hand, doesn't it?
Yeah.
Same with the ones going from the North Pole to North Pole to 60. Don't those look like they're bending to the left? They should look like they are, but they're not. What you have to do is you have to put yourself on the perspective of that arrow. So what I mean is you're going to have to put it so you're looking at the butt of the arrow, seeing where it turns. So if you notice, I turned my reference table over. Now that I'm looking at, like I'm going to walk that arrow starting at the butt and going to the head. Now is it bending to my right hand? It certainly is. So to figure out the right or the left, you have to start from the butt and go to the head. So you have to almost turn your paper over so that you can put yourself on the correct perspective. That's it. Don't forget, you guys still have 47 to do for homework.